Hi, this is Maria Gewerken for Database Systems, Assignment 3, Section B. The first, I had to create an ERD for the above description. Your ERD should perfectly show entity names, attributes, relationship names, cardinalities, etc. So I created 3 tables and 4 relations. The description says a course is an entity, part of our university system. A course must have an ID, course ID here. Um, Unique course code. It's a string, not null and unique. Course ID is a primary key and it's not null. This is an integer. Of course, my description and credits. Description and credits here. A course might belong to a department, and there are instructors who work in those departments. So, course teaches instructor. Course belongs to department. Instructor works in department. This is what it says. This is what it was talking about. Each course has its department ID, which is shown in this belongs relation. Each instructor has its department ID, and it works in each department. Each course can have 0 or many teachers. Each instructor teachers. Each instructor can have 0 or many courses. I thought that um, 0 or many instead of 1 or many, because an instructor might have, for example, a maternity leave, so she is still working in the university, but she might not have a course at the time. That's why it has 0 or many, and the course, for example, Startup Cultures, is a Janet course in AUA that isn't happening every semester. It happens once in 2 semesters, or sometimes courses that don't get enough students in it to start the course. So the course ID exists, and it's not going this semester, so it doesn't have an applied teacher to it because that semester it didn't it's not being taught, and so it doesn't have a applied teacher because some of the genets especially change the teachers every semester. uh, Belongs relation has one-to-one uh, courses, because course can have one department. I didn't consider the genets, for example, intro to physics, that can be computer science or data structures or engineering major, but it's one department, CSE, so I wrote one, and there is no course that doesn't have a department. A department can have 0 courses, 0 or many courses, because, for example, university might add a department and not add courses and teachers to it because it doesn't have enough teachers and supplies to start the courses for the department, so it can be 0. Instructor always has one or many departments. For example, Mr. Meher teaches probability for um, business, computer science, and data structure students. Also, some teachers are universally taught. So in universities where they are short on staff, mostly they have teachers that teach many departments. Usually they have only one, but still. Uh, Department has 0 or many instructors, the same logic as here, because sometimes the department doesn't have any courses, it's just a name. That's why it can have no instructors. I explained this. Prerequisites. Every course can have 0 or many prerequisites. That's why it's 0 or many, because the same course can be a prerequisite for nothing. For example, the course that you're taking in the first semester, last semester. Capstone. Capstone that isn't a prerequisite for anything because it's the last course you're supposed to take. And for example, Calculus 1 is a prerequisite for Calculus 2, and Linear Algebra is a prerequisite for many courses. For example, Probability, but I remember there is another one too. So it goes 0 to many because it can have no prerequisite. The course can have no prerequisites and be non non cursive has no courses that it's a prerequisite for, and vice versa. I explained the relations. Let's go to department. A course must belong to a department, and there are instructors who work in the department. Each department has its budget and building name. Budget, building name. Department ID is a primary key as it has a relation with the course, with the department ID. So it has department ID as a primary key in additional to budget and budget name. We don't have really much information about these two and these two, so it's just the name. Each instructor has email, phone number. Note the name is a composite attribute and should contain its composing elements. So I wrote it like this. I I think this is it covers it. First name, last name, name, when you call instructor in SQL. I'm gonna show you it later. Instructor ID, same as here. It has a relation to course, and each instructor should have an ID. And even if it doesn't have in the description in the assignment, every instructor has to have an instructor ID as a primary key, so the course can access it through teaches relation. Okay, let's move on to point 2. Reduce your ERD diagram into relational schema using MySQL Workbench. So, assignment 3. I have many schemas here, that's why I created homework 3 and wrote use homework 3 to be sure that the tables and everything I am doing here, it's doing it in the homework 3 schema. This is here just because I was changing the course all the time and finding errors no, wrong enters in it. That's why I was dropping and creating a new table again and again. Let me, what's this? Create table course. So as we see here, let me, do I have a cat? Okay. It's not getting smaller. As we see here, course has a course ID. It's a primary key, integer, and not null. The first one in course is course ID, integer. I took 20 because it's gonna be barely 10. To be sure, 20. Unique, not null. So, yeah. Course code, string, not null, unique. Course code, it's a string, so varchar. 10 because course code is usually like 6 or 7 characters. So string, maximum 10 characters, not null, unique. Description. A description, as I understand, is a string. It can be a few rows long. So to be safe, I took 1000. It might be short. I don't know. Credits, integer 20. Credits are usually 1, 2, 3, or 4. So one character, but to be sure, just taking 20. So if I take primary key and foreign key anywhere, I don't forget what number I used. So everywhere I used 20. Department ID. Department ID isn't in the ERD, but department ID is needed to be here for me to create the belongs relation. Primary key is course ID. Well, we already covered that. Select all from course. Let's run this. Control Enter. Okay. Course ID, title. Wait, this is the university database. Use homework 3. Select all from course. Course ID, course code, description, credits, department ID. Let's move on. Create table department. Department ID, as I mentioned, because of relationship and every table should have an ID. It's a primary key, so here primary key, department ID. Budget, budget name, budget is integer. Might be double. I could have used numerical, but budget is usually a round number, that's why I used integer. Building name is a character, might be a long name with like Stalin's grandfather's sisters, da da da. That's why I used 300 and it's unique. So yeah. It didn't say it's unique in the description, but I use unique because building names are usually, not usually, always in the same university at least. Let me close this. Let's see our weight table. Select all from department. Control Enter. Department ID, budget, building name. Right. Let's move on. Instructor. Primary key is instructor ID, integer, not null, and unique. Instructor ID, primary key, integer, 20, unique, not null. Great. Let's move on. So here, name has first name and last name, and we are supposed to have name as composite attribute and should contain its composing elements. To create a composing attribute, and so when I call the table, it doesn't show first name, last name, only shows name. I digged around in the internet, and if you have an SQL version 8.0.0 and higher, there is a new thing called invisible. You can use this to create columns that aren't showing. I created first name and last name as strings, invisible strings, and name is a composite attribute which takes 50/50 plus the space, 101 characters, and concatenates first name, tab, last name. So if I have, for example, Maria Gevorkyan in first name and last name in one row, it's gonna output the name, only the name. We're not gonna see the first name and last name. It's gonna have Maria space Gevorkyan in a column name. And when we want to insert something in the table instructor, we're not inserting it in the name. We're just inserting it in the Ertakondition as instructor ID, email, phone number, first name, and last name. Next thing we had email and phone number, nothing special here. Email is, oh, I wrote it as an integer. It's a varchar, maybe 100. Yeah. Let me fix this real quick. Drop table. This is why I spent 3-4 hours on this, because every time I was seeing a mistake, I had to drop it. Drop table instructor. Cannot drop table instructor. It's true. What's going on? Okay, let's select all instructor. Does this work? Here. See the name as we only have the name, we don't see the first name and last name. Why didn't it draw? Table structure. Okay, I don't know what's the problem here. I will fix it before I submit the code. Okay. I covered everything here, right? Okay. The primary key is instructor ID, as I mentioned. So first relation I wrote is works in. Instructor works in department. It has to have the primary keys of instructor and department to show which instructor works in which department or departments, vice versa. So instructor department we have as attributes both an integer, both are not null. Both are foreign keys referencing each table and the foreign key, and they are making a primary key together. Okay, let's move on. Okay, select all from works in here. Structure department ID. Prerequisites, another relation. Here, it goes zero to many, zero to many. It takes course ID and prerequisite course ID. Both are course IDs, but we have to see which one is which course is course ID. That's why prerequisite. So that's why I have two, and both of them are referencing to course ID here. References, both of them course ID, and we make a primary key out of the couple of them. Let's see. Next relation. Course belongs to department. So we should have the course ID and department ID for this. Course ID, department ID, initialized as the same way as in the course and department tables. Primary key is the tuple of them. Foreign key, each one is referencing to each one's table primary key. Select all from belongs. Here. Create table teaches the same way. Instructor teaches course. Instructor ID, course ID initialized the same way as in instructor and course. Primary key is the tuple of them. Foreign key, each one is referencing to each one's table. Let's see. Okay, next assignment says for writing queries using university database, which you can find on Moodle inside sample databases folder. Using join write a query. Okay, this is the database. It has a create that creates the tables and their columns. Insert that inserts 3,400 queries. So this is the code I wrote. Let's start. It's using the university database that created and inserted inside. First, using join, write a query to find those courses that require more than two as prerequisites. So we're taking the course ID, title, and counting the prerequisite IDs as numerical prerequisites, as number of prerequisites from course, because we need the number of courses that require more than two prerequisites. Not the number, the courses that require more than two prerequisites. So count prerequisite ID bigger or equal to 2. This one is taking the course title and course ID for us to understand which one is which. For example, if it takes only course IDs, we're not gonna understand. We need the titles to see what course ID is that. And we need to have the prerequisite ID taken in here, select, so it takes only the course IDs with prerequisite ID number is more than 2, for example, like calculus 1, calculus 2, calculus 3. If it has 2 or more prerequisites, it's going to show the list of courses with their IDs, with their titles, that have that. Okay, let's run this. Use university first, then this. Number of prerequisites. We created a number of prerequisites here and counting the prerequisite ID. So it shows how many prerequisites it has and gives us the queries of course ID and title where we have more than 2 prerequisites. See, 2, 3, and many like that. Next one, using the scalar subquery. And we did join here, if I didn't mention that. Using the scalar subquery technique, find the number of prerequisites for the given course, code 958. So simple enough, we're selecting the prerequisites. We count the prerequisites IDs from prerequisite column, where course ID is 958. All of this is in the same table course. That's why we're not joining or using anything else. We just take the course prerequisite table, and using the course ID is 958. Prerequisite table, just as the one that I created, has course ID and prerequisite ID, same, both referring to course ID. So it can access course ID easily. It's choosing only the ones that has 958 and counting the prerequisites. Okay, let's run it. So it found only 3. Next one. Find courses that do not have prerequisites using not exists. So it's selecting the course ID and title so we can understand which course it is. From course C, I just used C to not write course every time. Where not exists, select one from prerequisite, same here, same like this. Select one from prerequisites where prerequisites ID is course ID. Simple enough. If prerequisite ID is equal to course ID, it means that there are no prerequisites for that course. See? All these courses don't have prerequisites. Find courses that do not have prerequisites using left join. Okay, here. We joined course ID and we're taking course ID and title from course and using left joint to do left joint of prerequisites on course ID equals course ID in course and prerequisite tables. So where prerequisite ID is null. It takes the courses and prerequisites tables, left joins them, and giving us the prerequisite, the course and course title of the courses that prerequisite ID is null. So the same thing as the last one, but in a different way. Same answers. I was just nothing. I was just seeing how many are there. You can see very many. Next one. Using with clause, find the highest prerequisite number that exists for a course. Use the join for performing joins. With prerequisite counts as select course ID, count prerequisite ID as non-prerequisites. So it's gonna show us column non-prerequisites, which counts the number of prerequisites and chooses number prerequisites and course ID from prerequisite table, and it groups by course ID. So it's using with clause prerequisite counts. It shows prerequisite counts that is doing all this and selecting the maximum number of prerequisites. So it chooses the course that has maximum number of prerequisites and gives it the highest prerequisite count name from prerequisite counts. Prerequisite counts is this one. Okay, let's run this. Control Enter. The highest prerequisite count is 3. As we remember, because in an assignment up there, I showed that all of them were 2 or 3, so the maximum is 3. So this was all. Thank you for listening to me. I hope I wasn't too harle bacatrel because I was doing this for like 7 hours already. Thank you. Goodbye.